Hey everyone, Jason here. Over the last couple of years, while the pop-up book was gathering support, we would often bring it to events to show people how it worked, to try and gather more interest in the project. And I have to admit, at most of the events that Crystal and I were at, Crystal did most of the opening and closing of the book to show people how it worked. And at some point, she suggested that I really needed to build a machine that would open and close the book automatically. So finally, I have built this nice little book stand for the pop-up book, which has a mechanism in the back to do exactly that. The first part of the mechanism is this arm, which rotates from side to side and is loosely connected to this tab on the top of the front cover of the book. And as it rotates from side to side, it actually pulls the front cover of the book open and closed with it. And there's a couple of reasons that I'm using a loose connection here. One is that it makes it really easy to insert and remove the book from the stand. The other is that since the book has a compound hinge on its spine, if we look at the travel path of any given point at the top of the front cover as the book opens and closes, it does not transcribe a simple arc. So that the distance between that point and the center of rotation point of the arm will vary as the book opens and closes, which is why I have this tab at the top of the front cover, which basically just sits between a gap between these two wheels at the end of the arm. The second part of the mechanism is this engine block, which transfers the rotation of the motor to the arm. And it also reverses the direction of the motor every time the arm gets to one end or the other. Now, it would have been pretty trivial to use an intelligent controller like the Mindstorm ZV3 to automatically control the direction of the motor, but I really wanted to try and come up with a mechanical solution. Now, that mechanism is pretty hidden underneath the stand, so I built a standalone version of it so I can more easily show you what's going on. And I'm just going to run it for a few seconds so you can see it in action before I explain how it all works. And I've opened up the mechanism and disengaged the motor so we can really start to see how it works. To control the direction of the motor, I'm just using this Power Functions polarity switch, which is a standard Power Functions component. And the switch just connects to a battery box, and then a motor can be connected to the switch. When the switch arm is in one position, the motor spins in one direction. And when the switch arm is in the other position, the motor spins in the opposite direction. To control the position of the switch, I have this white control arm, which is connected to the arm that opens and closes the book. At the end of that white control arm is a ball joint with some rubber bands around it, which are connected to the switch arm. So that as that control arm moves to one side, it generates tension in the rubber bands, which pulls the switch to one direction. That will change the direction of the motor, and the arm will start moving the other way. When the arm gets to the other side, it generates tension in the rubber bands and pulls the switch in the other direction. And in that way, we just continuously reverse directions of the control arm. And this is actually all that's required for the mechanism to technically work. But you'll notice that the switch gets triggered when the arm is 45 degrees to either side of center, which is not far enough to fully open and close the book. So what we need is some additional mechanics to delay the triggering of the switch until the arm has traveled further. And that is what these red paddles are for. When we introduce one of these paddles into the mechanism, it will actually prevent the switch from being triggered until that white control arm pushes the paddle up and out of the way. And you can actually control the angle that the switch gets triggered at to a certain extent by changing the diameter of the wheel that you put on the paddle. Or for example, on this paddle, instead of a wheel, I'm using this short lift arm, which is actually larger than the radius of the wheel on the other paddle. And in that way, that white control arm will actually hit this paddle earlier than if it had a wheel on it. And so the switch will get triggered when this arm is at about 80 degrees instead of 90 degrees. And that's what I'm actually using on the model itself. I'm using these lift arms on the paddles because I actually only want the arm to rotate to plus or minus 80 degrees from center. And when we put it all together, we have an automatic oscillating engine. And the only other major difference to the mechanism in the finished model is that I'm driving it using an XL motor. And that's because it actually takes quite a bit of force to open and close the pop-up book. So the extra torque from the XL motor is definitely useful. And that is about all I wanted to talk about for this model. If you ask Crystal, I should have built it about 2 years ago, but you know, better late than never. As always, thanks for watching, keep on building, and I will see you next time.